Yeah. So, good morning, everyone. I'm Tarun from EDS Technologies. I will be the host for today's webinar. Firstly, I thank all the participants who have extended their time for this webinar on Build Brilliant Optical Design Flow with Synopsys. So, this is the agenda. I'll be introducing EDS Technologies and Synopsys and how EDS Technologies is partnered with Synopsys. Introduction of the speaker, and the webinar presentation will start. After that, we'll have a small Q&A session. So during this session, I would request the participants to type in your queries, or if you want to speak up, you can raise your hands so that I will allow you to speak up and put your questions forward. And we will also be letting you know the upcoming workshops and webinars and the inquiry details. Okay. So, introduction to EDS Technologies. We are one of the largest technology solutions provider in India with close to 30 years of business transformation experience. EDST helps transform businesses by enabling adoption of virtual twin, geospatial analytics, and 3D printing. We have introduced many technologies in the industry like 3D printing, virtual reality, digital manufacturing, etc. for the first time to the Indian customers. We established as a trusted partner for more than 2,000 organizations across various industries, including automotive, aerospace, defense, industrial equipment, mining, and many more. We have dedicated regional teams reinforced by our domain and functional consultants. We are backed by these strategic alliances with global leaders who are pioneers in their respective technology areas. We are widespread with the presence with 10 offices across India, and we have end-to-end technology solutions provider to our customers. So we have 2,000 plus associates working in EDS Technologies, 2,000 plus customers, and we have presence across 10 locations, having headquartered in Bangalore. We have offices in Gurgaon, Noida, Ahmedabad, Kolkata, Pune, Mumbai, and Chennai, and Coimbatore. So introduction to Synopsys. So Synopsys is a valued partner for the global silicon to systems design across a wide range of vertical markets, empowering technology innovators everywhere with the industry's most comprehensive and trusted solutions. Autonomous machines, data centers, billions of smart connected technologies. The innovations Synopsys is powering today are helping to ignite the ingenuity of tomorrow. Three major technology trends: artificial intelligence, silicon proliferation, and software-defined systems are shaping a new era of pervasive intelligence. For years, Synopsys has been a driving force of these trends, delivering the silicon to systems design solutions that are being essential to enable them. EDS Technologies is partnered with Synopsys in various technologies. So we are partnered for the EDA technologies for the designing of system on chip, field programmable gate arrays, verification of the chips, silicon IPs, and manufacturing of the semiconductors. And next is the virtual prototyping, which is for the physical modeling, simulation, and virtual ECUs. Next is the academia. So we empower the academia with Synopsys Center of Excellence tools for the VLSI tool flow, virtual prototyping, and semiconductor manufacturing. Next is the optical design, which which we are going to highlight on in today's webinar. So it is on the optical design and simulation, automotive lighting design, night drive simulation, and photonics. I now introduce Ms. Isa Liu, who is the lead application engineer in Synopsys International Corporation at Taiwan. So Isa has more than 14 years of experience in the optical solutions. Currently, she is leading an application engineering team at Synopsys, Taiwan. She provides product support and integrated optical solutions to the customers in Greater China, Southeast Asia, and India. So over to you, Isa. Now you will start your presentation.
Okay. Can you see my screen now?
Yes, we can see a screen.
Okay. Good day, everyone. Now I will share about the optical design solutions with Synopsys. And sorry, in the beginning, because Taryn just introduced Synopsys, so I may just very quickly to give you an overview of the Synopsys. We have 37 years history in the EDA, the IP, and the AI-powered EDA support. And we still invest 28%, almost 30% in R&D every year. Okay, and for the optical part, the journey can trace back to the 1963. In 1963, ORA established, and in 1975, COFI released, and in 1995, LightTools released. Those are the optical software to provide a solution to the image design and the illumination design. And in 2010, Synopsys acquired ORA. So that means Synopsys started to the optical solutions provider since 2010. And in 2012, we also acquired RSoft to provide the photonics solution. So we started to integrate the ray tracing and the photonic solution together to offer more comprehensive solution to the industry since 2012. And until now, I think we still provide the solution to many applications. And I will have more detail about the applications later, and we'll also share more about the COFI LightTools and other optical softwares. Yeah. And the market we serviced, including data center, networking, mobile, automotive, AR, VR, healthcare, and etc. I think many industry, they including the optical component in the system. So optical is actually everywhere. So no matter the geometrical optics or the wave optics, the behavior can be controlled or used in many different domains. So, and how can the software help you in each applications? I think we continuously to develop the software to provide better optimization function and provide some expert tools so that the designer can design their optical system better and faster. And also, we provide the tolerancing capabilities to generate more accurate result, and it's the as-built result. Not only very virtual simulation, but also consider the manufacturing impact in the simulation, so that we can provide the virtual prototyping to make the products design faster and better and shorten the time to market. And the optical products we offered, we can show from this page. The COFI is the first product, as I mentioned in the previous slides. And COFI is in the imaging design applications. So we can use COFI in any type of lens design. And his lens optimization capability and various analysis capability, also the tolerance capability, can help designer to design better. And LightTools, it is used to the illumination design and simulation. So many kind of illumination system, we can use light tools to do the simulation, to do the optimization, and also the visualization. And nowadays, I think many optical systems like the AR, VR, or the automotive, it all including the illumination part, and so that we can use light tools in all the domain. And I think later we will see some application may give you more ideas about how we can use the software in the applications. And the third product is LucidShape. LucidShape is very dedicated to the automotive lighting design. So we can use LucidShape to do the headlamp, tail lamp, and light guide design for the automotive. And we also have the RSoft, as mentioned, is about the photonics device design. Means when we need to consider the wave behavior, not only the ray behavior. In this case, we need to consider the use also to simulate the phenomena. So, for example, the silicon photonics, that is one of the application that we can use RSoft to do the simulation. And also, nowadays we use more and more diffractive optics elements in the system. Then it need to consider the diffractive effect. So we also need to consider the wave optics. Then we need to use RSoft to do the simulation and design. And besides the software, we also provide the hardware. It's the optical scattering measurement system. So we can get more accurate surface properties to use in light tools and LucidShape to get a more accurate result. We also provide the optical engineering service to the to join the project with our customers. Okay, and so then I will discuss about each software more details to let you know how is its advantage. For Ko-Fi, we have already know that it's for lens design, the imaging design, and Ko-Fi has provide the easy to use GUI interface so that we can set up our system flexibly and and we also can use the command line to operate the whole systems. And Ko-Fi has the very outstanding optimization function. It separates the constraints and error function so that we can have better control in the optimization, or you can call it automation design. And Ko-Fi also provide a global synthesis. You can treat it as a global search of the optimization to explore more about your solution base to get better solutions. And in Ko-Fi, we provide many tolerance features that users can use to reduce the tolerance sensitivities. Okay. And we also provide some expert systems like a sphere expert and gas expert to help designer to select the best position, best surface to define a spherical surface. And when we finish the nominal design, we need to use the real glass. So the glass expert in Ko-Fi can help us to substitute the real glass to the system and maintain the optical performance. And we also provide many different tolerance analysis methods. And the TOR, the TOR capability, is 100 times faster than the Monte Carlo. So because it is so fast, we can control the tolerance during optimization to real desensitize in the optimization process. And CoFi also provides a 2D imaging system simulation result, so we can get the imaging result for the analysis. It's very intuitive. And if you want to consider partial diffractive effect in CoFi, we also provide the beam synthesis propagation, we call BSP in CoFi, so that we can have more accurate imaging results. Okay, that is about CoFi. And Light Tools is the illumination design tools, and it has the 3D CAD environment for users to build up the system. So you can use its 3D CAD to set up your source, your optical element and the receiver in the windows, and then also do the simulation and optimization. And when we need to consider the wave behaviors in the illumination systems, we work with Rsoft, the wave optics tools, to calculate the behavior and save as the BSDF data, and then we can apply the BSDF in Light Tools to consider the whole wave effect in the whole systems. And Light Tools provide very unique interactive approach, that is the point and shoot, or we call the NS-ray, to trace the ray immediately and can help us to predict the illumination results very intuitive. Okay, and we also provide many different optimization algorithms, including the standard algorithm, alternate algorithm, and the global search algorithm to use in different system for the optimization. And Light Tools also provide the tolerance and the multi-configuration features to let us to consider more about different configurations. It also provides rendering features so that we can have the rendering result in Light Tools. Okay. And Light Tools, we partnership with SolidWorks. So in addition to some CAD convert feature, we also have the dynamic link with SolidWorks. It means when we use the SolidWorks link module in Light Tools, then we can modify the models in SolidWorks, and it will change the model in Light Tools as well. And the define of the surface properties and the source can also link it to the Light Tools. So it can greatly reduce the setting times between the CAD and the Light Tools. Okay. And next tool is LucidShape. LucidShape, as mentioned, is for automotive lighting usage, and it provide very comprehensive analysis function for the automotive lighting. And it offers an integrated design environment that us to construct the model and evaluate the performance. And LucidShape has the functional geometry design we call FunGeo, and it can help to create the model to make the specifications, and also include some library of the light source, lamp, and LEDs. And LucidShape also supports smart stop materials library, including the surface and the bucket materials, so that we can define the properties from the library to do the more accurate setting. And LucidShape has the multiple ray tracing engine. including CPU and GPU. It helps us to calculate faster and to get an accurate result. Okay. And Lucidchip also provides a backward illumination camera and human eye vision imaging tools so that we can illustrate the realistic photographic results as shown in here. Okay. And Lucidchip has the CATIA base. We call it Lucidchip CAA. So for that Lucidchip CAA, the environment is embedded in the CATIA. So if you are the CATIA user, you can very easy to use the environment because it's just same as you use the CATIA, and set up some other light source and optical properties and parameters, and then can perform the simulation and analysis in CATIA. And after CATIA v5 release 33, you will only support Windows 7, and the Lucidchip will be the only optical tools that can support that version. Okay. And Lucidchip also have the products called Lucid Drive. It's for night driving simulation. So we can use Lucid Drive to show the night driving scene as shown in the slides. And we can also do the beam pattern analysis of the different combination of the headlamp. So you can add the different type of headlamp to your automotive and see the results through the Lucidchip dynamically. Okay. And we also have the multi-view display mode to show wider view like shown here. Okay. And the next tool is the photonics solution. And in Synopsys Photonics Solution, we have three parts of the products. The first one I will describe more is the photonics device tool. And besides the photonics device tool, we also have the system tool and the layout tool called Peak Design Opto Compiler. But I won't discuss about the system and the compiler, but I will talk about more about the photonics device tool. Okay. And in photonics device tool, we have 7 algorithms to calculate the wave behavior. So in different systems, we can use the most effective algorithm to do the simulation. So for example, if you are doing a fiber or waveguide device, you can use beam prob BPM. It's beam propagation method based, so it can very efficiently to calculate long fiber and long waveguide. And for the very basic, any kind of photonics device, you always can use full wave. It's the FDTD based. So any photonics narrow structures, you can use full wave to simulate. But FDTD based is more time and memory consuming. So for different structure of the situation, we can choose other algorithm if it's suitable. For the benzoff, we use the plane wave expansion to do the photonics crystal device calculation. And for the grating fiber, we can use grating mode. And for waveguide or cavity mode calculation, we can use the fencing finite element method based to calculate the mode. And if you are using some silicon photonics simulation, you can consider to use mode prob to do the simulation. And for the periodical diffractive grating structures, you can use different mode. It's RCWA based. It's very efficient in the periodical structure simulation. And we also offer some utility like the most to provide the optimizer and the scanning tool. And if you are doing the semiconductor laser design, you can use laser mode. We also have some other utility for the LED, solar cell, taper laser. Recently, the Meta surface design is very popular. So we also offer the Meta Optic Designer for this application. So here you can see the Meta Optic Designer. It provides very easy to use interface for users to just set up the input source and the output pattern. Then the Meta Optic Designer provides inverse design capability to help us to arrange the meta atom and can get the result as we target. So this is the Meta Optic Designer help us to lay out the meta atoms. So when the like the Gaussian beam input through the meta surface will get the optimized pattern just as we desired. Okay. And for the measurement, we have different accuracy levels of the measurement equipment. And if you want to have more quicker measurement and more portable, you can choose the mini-D feature. It's portable like this. And if you want to have very accurate measurement, then you can use the reflet to measure the scattering distribution. And we also offer the TIS Pro. It's an optical scattering instrument for the reflectance, transmittance, and absorption measurement. So that is what we also offer with the equipment to measure the surface and the optical properties. Okay. And with those measurement equipment, we can measure including the surface properties and the absorption to the bulk materials. And so we also offer the library about from our measurement. We call it Smart Star Library. And both Nitrous and Lucidship can use the Smart Star Library to set up its optical properties. Okay. And as mentioned, we also have the optical engineering service. If you have this requirement, you can also contact us. So we just talk about the Ko-Fi, Nitrous, Lucidship, RSoft, and the measurement equipment. And those tools can integrate each other to provide more capability in the more complex systems. So here we can see how we leverage all different optical tools to the different products. Here we can see we can support from design to simulation to products. Here we just take the imaging, illumination, and automotive lighting as an example. In these domains, we usually can use Ko-Fi for lens design. So any type of lens design, no matter is for camera lens or projection lens or other collimator and so on, we can all use Ko-Fi to do the imaging design. And the design lens can be exported to like the EG step or SAT format. With the light tools, we can directly convert the Ko-Fi models to light tools. Means light tools can open Ko-Fi model directly to do further setup, like the mechanical part setup and the straight line analysis or the whole system simulations. And we also can use Lucidchef CAA to import the IG step or SAT files and do the next simulation, like the advanced analysis to check if the result pass the regulations. Okay. And in the simulation, we also can leverage our software to deal with the defective phenomenon so that we can get more accurate result to include the defective behavior in the whole systems. And we can also provide a visualization, no matter from light tools or leadership product, to get the visualized image results. So those products can use in the automotive and other like lighting or the camera domains. And if we want to get the surface property more accurate, then we can leverage the BSDF instrument to get more accurate properties. Okay. And so further explain about how we use those products in the pixel light headlamp. You see, we can use Ko-Fi to design the projection lens. In pixel light headlamp, we usually use the projection lens to project the razors to the road on the road. So the projection lens is necessary and it should be designed with Ko-Fi. And then we can save the lens as EGIS file, step file as SAT files, and we can use the CATIA to open the file, or we can we can import those files to Lucidchef. And then we can do further simulation to include the mechanical parts or to do the whole illumination result. As mentioned, we can check if the result pass the regulations and also give the visualization result as showed in the here. And we can also explore the lighting distribution to the LID or IES file format and import to Lucid Drive to see the night driving, to do the night driving simulation. And here you can see the example of the pixel headlamp. So the light will project it on the road, and you can switch on and off each pixel to phone the signal you want to project to the road. Like here, we project a Synopsys to on the road. Yeah. So this is the pixel light headlamp example. And for automotive, we can also use the software to do the head-up display design. Usually, we can use Ko-Fi to do the lens design, but in light tools, actually, we also provide some functions that we can do the basic design of the head-up display. And we also can check the distortion or the ghost results in both Ko-Fi and light tools. And in light tools also can provide the visualization result as shown here. And we can add the solar source in the system to see the impact from the solar, because sometimes it may cause the glare, so they may influence the driver to to see the street scene. So we can do the simulation analysis in light tools. Okay, and for AR glasses is another application that is quite popular recently. And for the AR glass, we can use Ko-Fi to do the collimator design and to make the display into collimated rate and into the AR system. And then we can use light tools to do other parts set up. For different type of AR VR system, we will set up differently. But no matter which type, that the bird-based, the pancake, the waveguide, grating AR, or freeform lens AR, we can all use the Ko-Fi and light tools to design and simulate together. And for the waveguide grating, the diffractive type of AR glasses, we will also include the BSDF in the whole solution because we use the BSDF to simulate the grating and save the grating behavior as a BSDF file, and then we can use apply the BSDF file in light tools to get the whole system, including the diffractive behavior. So here you can see this is the waveguide grating type of AR glasses. So in here we use the diffractive, the DOE, the grating area to bend the light to the light guide. So in light tools, we apply those properties on. Then light tools can get the whole system simulation and get the result. This is the results showed in human eyes, and this is the source we projected from the display. So we can see how the human eyes can observe from the glasses. Okay. And another application is a cell phone lens design. So in this design, Ko-Fi is always for the lens design part. And if you want to include in the meta lens in the system, you can also use Meta Optic Designer to design your meta lens or your meta surface. And light tools used to set up the mechanical parts, the spacer, the barrel, and to the environment source, and we can analyze the straight light and the visualization in light tools. And if we want to consider again the diffractive behavior in the camera systems, like when light hit on the CMOS image sensor, we may have the diffractive reflection from the surface. Then we can use ourselves again to calculate the diffractive distribution. So as you can see here we can see the petal flare is caused by the diffraction of the CMOS image sensor. So light tools can combine the diffractive behavior and the lens together. It means we can integrate with Ko-Fi and Rsoft to perform the whole system result. Okay, and besides the pixel headlamp, the head-up display, actually there's still many different design in the automotive, including many different cameras, the backup camera or other cameras, and we also can design LiDAR with our tools. So any optical components design, you can always think about use Synopsys tools to do. So if you have any requirements for any kind of optical design, then you can consider to contact us. Also for the AR/VR application, not only the whole system. You may also want to design the micro LED. Then we can use light tools or also to do the primary design or secondary optical design. And meta lens is also a component that the AR/VR maker want to include in the system to make the system more compact. And you may also want to design the coating. Then you can also use the RSoft or Cofile light tools to do the design. And for eye tracking system, this is the model we build up and simulate in light tools. So you can see when I rotate to different angle, then we can analyze the light spot distance between the LED spot and the eye and the eye, the pupil. Yes. And this is the mobile device applications. We talk about the camera design that you can use Cofile to do lens design and use light tools to do the whole system simulation and include the diffractive effects from RSoft to see if there are the diagonal flare or other straight lines in the image. And we also can use the tools to do like the PPG sensor. We can build up the skin model in light tools and with the volume scattering behavior, and we can set up the transmitter and receiver in light tools and design a lens to receive more rays and to see when the in different situations we can measure the power of the receiving rays to know to just like the PPG sensor it behave. Okay, and in the mobile phone, some mobile also use the structured light to recognize the face ID. So in light tools, we can also do the simulation. And if you use the diffractive optics to scatter the light, then you again you can use RSoft to do the design and the simulation, then apply the properties into light tools. And in light tools, we can see how the dot projecting to the face and see how it distorts. Okay, and for the LiDAR simulation, we can use Cofile to do the lens design. And in light tools, we have the optical lens mesh, so we can know how for different beams of the mesh, what is the optical lens. So that the data can be used to do the algorithm for the LiDAR calculation. And some mobile phone also use the in-display optics. For example, they may place the printer scanner under the screen or put the camera under the screen. So if we want to simulate if the screen impact the performance, then we can use light tools and RSoft. We can use RSoft to calculate the diffractive behavior and set up in light tools to see if the diffraction impact the image quality. Yeah, like here we can see the finger printer and fingerprint fringe if it is too noisy or if it is clear. Okay. And here we just show the diffraction effect because in the display there are many like the white balance and the pixels of the like the OLED or micro LED, then all those patterns may cause the diffraction effect. So we can simulate this part in RSOT and then get a result in light tools. And for other display applications, we can design a light guide in light tools. So we have the tools to dedicated to design the light guide plate, and that or phosphor for the LEDs, and we can visualize the how when we place the micro LED with different pitch or different positions, then how is it visualized by the camera or the human eyes. Okay, so that is about the recent topics about the application, including the AR, VR, mobile, and the automotive. Yeah, but as we discussed in the beginning, actually the optics of the photonics is everywhere. So maybe you will have the inquiry besides the automotive, mobile, or AR, VR. And if you have any problem or question about the optical design or simulation, you can always contact us to seek for the solutions for your design. Yeah. So above is my presentation. So we can open to the question now.
Yeah, Isa, thank you so much. Just a minute. Yeah, so thank you, Isa. Now we will move to the Q&A segment. So we have a question from one user. Just a minute. Yeah, so one question is, can we use code 5 as non-sequential ray tracing? Is one of the questions that one participant has asked.
Okay. Code 5 has the non-sequential ray tracing mode in as one of its function, but usually we will recommend you to use light tools or Lucy-Shape to do the non-sequential ray tracing. So based on what you want to do, if you just want to do very basic simulation of the non-sequential, yes, you may be able to use Code 5. We have the non-sequential mode to define in certain surface will behave the non-sequentially. But for more complex behavior with more mechanical part, then we highly recommend you to use light tools for straight line analysis, something like that. Yeah.
Okay, thank you, Lisa. And we have one participant named Akash Anand who has raised a hand. I'll just unmute. You can ask your question, Mr. Akash.
Hello. Hi, sir. Can you hear me?
Yeah.
Yeah. First of all, thank you, ma'am, for this brief introduction of all the software, and it was great learning actually. And you have given a brief idea like its software capability. So, but I would like to know, ma'am, one thing. Like since Synopsys just recently has taken over this ANSYS, so ANSYS provides this GMAX Optic Studio software that is also a leading software for the optical design. So just I would like to know like which one is the better, like the software, like for the optical design, like it's GMAX or Code B or some other.
Hello. Okay. So I think you asked about between Synopsys and ANSYS. I think yes, we also the news uh, announced about the acquisition uh, by the acquisition between Synopsys and Ansys, but it is still in progress. So now we still treat as a separate company, and so I think each software has its advantage. So it will very uh, based on your requirement, your design requirement. And as usually, we highly recommend Ko-Fi to the lens makers, because if you want to have a more um, accurate, or you want to consider the tolerance during the optimization, then Ko-Fi will be always your best choice. But in after if we after the acquisition, maybe we will have some different change in the integration, but we don't know yet. So now we just still treat it as the uh, individual standalone software. So if you have specific problem want to solve, that we can discuss further which product is better for you. Yeah.
Thank you, user. And we have one more question from user Himanshu Verma. Mr. Himanshu, you can speak. Mr. Himanshu Verma?
Yeah. Am I audible now?
Yes, please.
Yeah. Thanks for the session. I have one question regarding this. You provide a service of measurement of BSDF values. So I need some contact. Whom should I contact? Because a couple of times I have put this in the website for the request for quotation and inquiry, but I didn't get any response from Synopsys. So I need some contact whom I can contact.
Oh, okay. So I think after this slides, Tarun will show you the contact information. Then you can contact to uh, the EDS technologies, and we will reply as soon as possible. I think because Synopsys provides many different solutions like the EDA and IP, so maybe on the website, the contact information is not very proper to you. So I'm sorry that you didn't get response. But I think if you email to EDS technology, they will respond to you quickly. Yeah.
Okay. Thank you.
Thank you.
Thank you, Mr. Himanshu. And we have one more question from Mr. Arbinda Luha. Mr. Arbinda, you can ask your question now. Can you unmute? I'm trying to unmute.
Hello.
Yeah, please.
Am I audible? Yes. So,
Yeah.
seeing this webinar, I have observed that these softwares are more kind of interdependent in simulations. So, I would wanted to know how independent is code V in designing and simulation also for optical system. Will code V will be sufficient in designing simulation of a complete camera system?
The voice is a little bit lower for me, so I'm not sure if Tarun you hear clearly. Can you repeat the question again?
Hello. Yes, I would like to ask, how independent is code V in designing simulation of optical system? As I am seeing that this webinar, I have observed that these softwares that you have mentioned are more interdependent in simulation. So my question is again, will code V will be sufficient in designing simulation of a complete camera system?
In what system? In camera?
Yeah, camera system.
So is the question about how Ko-Fi used in camera system design?
Hello.
Hello,
Actually,
because
he's
I
some
trying
word
to
is
ask.
also typed this question.
Yeah, Isa, he's trying to ask, is Code 5 self-sufficient for a camera design, or is it interdependent on other tools as well? Arvinda, am I right? Is this your
Yes,
question?
yes, yes, yes,
Yeah.
yes.
So camera design itself, Ko-Fi is sufficient, but some designer they also want to do more and more complex straight line analysis. Then we will also use line tools together. But if you just want to design a camera with some like the second reflective ghost, then you can use Ko-Fi itself. But you want to consider more complex straight line, then maybe because many lens makers they also do straight line simulation in different illumination tools. Yeah. So in that case, we will also use light tools. Yeah.
So in stray light simulation is not there in code view.
Is straight line simulation what?
Is it not available in code view?
Um. Because Ko-Fi is still more sequential ray tracing, so we can define. Usually, we just analyze the ghost in Ko-Fi, and we can reduce the ghost during the optimization in Ko-Fi. That is okay. There is no problem. But if we want to consider the straight line alter the field of view, then we will use light tools to do the whole simulation. And some designer, they also want to consider the sensor noise or some ISP, then we will have other different tools to do that part, because that is already beyond the lens design itself.
Okay, thank you.
Thank you.
Thanks, Arvinda. Isa, we have one more last question from Mohan Raj. So his question is, which software will be helpful to find the effect of sunlight on the instrument cluster of tractor or open roof cars?
Can you repeat again about the question? Is about the instrument cluster,
yeah, of tractor
design
and open roof cars.
Open
roof cars. You mean open roof cars? Yes.
Yeah. I think if you want to design the instrument cluster, they usually use many light guides for the design. So for the light guide design, and if you want to have the very stylish, then the light guide may be very different geometry, then we can use light guide designer to design the light guide and to get a more uniform illumination results. And this should be used Lucidchef CAA CATIA based. But if you are not a CATIA user, then you can consider to use light tools to do the design.
Okay. And one more question, Isa, like how do we avoid the temperature whitening and blurring around the lenses? See, one of the major issues in the optics design is the temperature management. So how do we address this, and which tools are used?
Okay, and to consider the lens design, the image quality in different temperature, CoFi provide features. The latest one called MECO, MECO, that is for design with different temperature. For example, we can put the working temperature, the lowest and highest temperature for different zone, and into the CoFi, and CoFi will set up the zone automatically, including the spacer and the barrel expansion. So the lens spacer will change, and the refractive index will change as well. And CoFi can optimize to get the best solution among over the whole temperature to get, we call the assembleized design. So CoFi has a capability to do the assembleized design. So that is the, yeah, it's a part of the lens design process.
Okay, thank you. So let's close this Q&A for now. You can send us your questions. If any more participants have your questions, you can send our questions to the email address. We will be displaying it shortly. And so here is the upcoming workshop and webinar. The first one is the webinar, Illuminating Strategies for Perfect Light Guide Homogeneity in Lucid Shape CATIA V5 based, which is happening on 27th of June from 2:30 to 3:30 p.m. Indian Standard Time. And here's the agenda. And the second workshop is Devian India, which is happening in Pune on 4th and 5th September. The session is on Indian vehicle and vehicle lighting market, design and technical trends, LEDification and softwareization, 2- and 3-wheeler lighting specification, design, technology, cost, and India-specific lighting requirements, design, reliability, contamination, and usage. And there is a panel discussion as well. So we will be sharing you the details of this webinar and workshop for all the participants over the email. So we wanted you to get the maximum benefit out of it. And for inquiries, you can mail it to me, and as well as Aniket, and we have the contact number also displayed. You can contact us directly. You can contact me. I am responsible for the Synopsys products in EDS, so you can call me or email me directly. My name is Tarun. I hope it is displayed in your screen. You can note it down, and your queries are welcome. If you have any questions, you can mail it to us directly. We will get it addressed directly from Synopsys. Okay, so I thank you all the participants, and I thank Isa for giving this very insightful session on how brilliantly any optical design could be. So thank you one and all participants. We will share the other details to you over the email. So thank you everyone.
Thank you.